Alrighty, so say you want to make a game or an application, or you just want to solve a problem, whatever. But you're just paralyzed as to where to start, and you're just staring at a blinking cursor that crushes your soul by the minute as you question your life decisions while your life flashes before your eyes. So every programmer has been down that hole before. Some never get out, some quit, but we're going to make it out. So really, programming can be distilled into 5 sort of questions that you need to ask, or 5 fundamental steps. So let's see them really quick. They are, what of the 3 types of data, being strings, numbers, and booleans, is best suited to represent what I need? Number 2 is what operations can be done to the data to get to where I need or want to do, right? And when I say data, I mean it's either usually one of these 3. Number 3 is what conditions do I need to consider, test, and account for. Number 4 is what parts of data are related and can be grouped together. And 5 is what parts can be generalized. And this is sometimes involving using a function. It's sometimes called abstraction, refactoring. There are a lot of times associated with this. And this is probably the most hardest and weirdest one out of the 5. Alright, so we're going to apply this to a context of making a game, and we're going to walk through this like a checklist so that you guys can see how programmers really think. Alright, so let's go. So let's go to main.py, copy this, paste it in here. Alright, so it's a blank page initially. I don't know what we're doing, you don't know what we're doing, but let's get through this. So I said we wanted some notion of a game. And what do games have? Well, games have monsters and players. Well, what do they have? So monsters and players probably have things like health, they have attack points, and they have a name. So on step 1, what of the 3 types of data, being strings, numbers, or booleans, is best suited to represent what we need? So pause the video and try to take an educated guess. Alright, so spoilers. Of course, monster's health should be represented by a number. So we can call it HP is equal to, let's say, 10. Its attack points is better suited for a number. So we're going to say it's 12. And let's say its name is better suited for a string, but it can be a number. That's on you though. We're just going to say its name is a monster. So I mentioned that there would be a hero also. So the hero has the same sort of attributes as the monster. So let's just copy and paste that. Player, and hero. Alrighty. So that is step 1 of this. What of the 3 types of data, being strings, numbers, and booleans, is best suited to represent what we need. Moving on to step 2, what operations can be done to the data, right, these pieces here, to get to where I need or want to do. So by operations, we want some sort of motion to act on these pieces of data, right? We want them to change. And what we want, or what we want to do, or where we need it to be, is that we want some notion of someone getting hit. And pause the video to see what sort of movements we can apply on these pieces of data that will sort of represent someone getting hit. So we're going to go over spoilers in 3, 2, 1. So someone getting hit is really their health points getting reduced. So let's say the monster gets hit, right? So its health is equal to its old health before it got hit minus, let's say, the player's attack point. So right here. Alright, I'm going to make this 20 so that we can get some more variation. And we're going to print its health out. Print monster HP. There we go. We're going to print this before so you guys can see the difference. Before monster HP. I'm going to do the same for the bottom part. And okay, so we're going to run this code, and we see that before its health was 10 right here, but then when it got hit by the player, right, this is going to be 10 minus 20. We're going to put it back into the monster's health, and it's going to be negative 10. So after it got a hit, its health is now negative 10. and that is step 2. What operations, right? Operations here can be done to the pieces of data to get to where we need or want to do. So let's move on to step 3. What conditions do I need to consider, test, and account for? So let's say we want some notion of death. Well, what condition is that on these pieces of data? So the condition, let's say off the top of my head, it's like, well, if a monster's health or someone's health is equal to 0, right? We have 0 hit points. Then we're going to print no. All right, let's run this code. And it's not working. So there's a subtle bug in this. Pause the video and see if you can figure it out. We're going to go over spoilers in 3, 2, 1. So the bug is that the monster's health is not equal to 0. It's less than 0, right? Because after we hit it with the player's attack points, right, it's 20. 10 minus 20 is negative 10. So to fix this bug, you can just go change this to a less than. So if the monster's health is less than or equal to 0, then we print no. So let's run, and that we see it works. So this is a blind spot. As you program more, you can get more faster and quicker at recognizing blind spots. But let's say that you're tired and you don't know how to find the bug, and it's like 5 hours in, and you're just how would you find this bug? And really, most programmers use print statements here, right? So they're going to see that, oh, it's not printing no here. So I'm going to look up and see that, this condition is probably false. We got to find some way to make it true. And they're just going to figure it out and put a less than sign there. But let's say that, you still can't figure it out and you're just really, really tired. Most programming languages come with a tool called a debugger. I'm going to use one built into Visual Studio Code. Alright, so I pasted in our code, and we're going to set a breakpoint. And what a breakpoint is that we're going to pause execution here so we can step by line and see what's happening. Alright, and if you can't set this for a dot, you need the Microsoft Python extension. But anywho, we're going to pause the code here. We're going to go to run and debug this file, and here we go. Alright, so it's going to pause execution here. So right now, it's applying the attack. So these are our variables. So right now the monster's health is 10. After we step through this line, it's going to be negative 10 because we just hit it. Alright, we'll print the monster's health after. Okay, my terminal is not working for some reason. Whatever, we'll just keep going. So if the monster's health is equal to 0, if we step down, we're not going to see it hit anything. And of course, let's fix this and see what happens. We do. So I'm going to set the breakpoint here. I'll run and debug again. And we can keep stepping down and see that this line is finally highlighted in yellow and that we actually run the code. And for some reason, I don't know why, it should be printing no here. Why is it not printing no? I have no idea. Anywho, that is how you find the bug, and that is step 3. What conditions do I need to consider, test, and account for? So let's move on to step 4. What parts of data are related and can be grouped together? So here we're seeing health, attack, name, health, attack, name, and we want to link these together into one cohesive unit. Because right now there's not really any relationship between these variables, other than that we named them with prefix underscore, right? They're not really one cohesive unit. And to make one, you use a record type. And every programming language has one. In Python, I believe it's called a dictionary. It's called a struct in other languages. But this is how you express it in Python, as far as I'm aware. So we're going to make a monster record. We're going to say that its health is 10. And we're going to say its attack is 12. We're going to say its name is monster. And let's see, undefined name attack. So we're probably gonna have to quote these, I would guess. Yes, these names that be quoted on the left. Let's do one for player also. Let's go to HP. I can just copy paste this honestly. Player, its attack is 20, and its name is Hero. So I'm gonna comment these out because we no longer need them. So now, right here we had 6 variables, right? 2, 3, 4, 5, 6, that were unrelated and just free floating in space somewhere. But here with records, we have one whole units with attributes right here. So to make this code on the bottom work again, we're gonna have to account for treating, getting the pieces out of these whole units. And to do that, it's the name of the variable, or the name of the container that has this record type, and in quotes, it's the name of the field. So we want its health here, and we're going to speed this up by Control F, monster, bracket, HP, there. So we're going to replace all instances, there, and there's only one player attack, so I'm just going to type that out. Player attack. So what these do is that they get the pieces of data out on the right hand side, and we index them with the name of the field. And that is how we group pieces of data that are related, which is closely intertwined with step 5. Speaking of step 5, what parts can be generalized? Right? This is sometimes called using a function, abstracting, refactoring. So really here, let's say we want the player to get hit by a monster. So to do this, right, of course, we would just paste this in now and say that it's the player that's taking the damage from the monster. So this is not that flexible. There are pieces that we can generalize here. So as you can see in these 2 lines here, the only differences between them is that this is a monster here, and this is a player here, and this is a player here, and this is a monster here. And we can tease pieces like these out into a function and make it more generalizable. And to do that, let's just create some notion of hitting, right? All we want to do is express some notion of hitting, and that can be distilled into just an attacker and a defender. Alright, so we're going to copy and paste the same logic because it's pretty similar. And instead of hard coding it so that only monsters take damage from players or players take damage from monsters, we can parameterize and plug and play these 2 concepts. So instead of a monster's health, let's just say some defender that you give me is going to take damage, and some attacker is going to attack, and yeah. So this expresses the same concept as before, but now our program is more flexible because I'm going to comment this out. Delete. Same concept as before. Let's fix this bug here. Same concept as before, but now we're more flexible because let's say that we want, let's say there's some internal strife, right? And we want like a player to attack a player, or let's say that we add like an NPC. This should be player 2. Say we add like an NPC or something, right? An NPC is going to get hit by a monster. We would keep having to sort of paste these lines of code, but with this more generalized version, right? We can do instead hit. We're going to pass some notion of an attacker. Let's say that it's the player attacking the monster. And if we just want the other way around, we just do the monster is now the attacker, and the player is going to take damage. And if we're going to add an NPC, it's just this, instead of like this. So that generalizes our piece of code here and makes our program more expandable and more easy to maintain. And really, this is one of the harder parts that you're going to face. I wouldn't recommend that you do this prematurely. Usually you write code like this and you go, oh, well, these pieces look identical, so maybe they can be generalized. And this takes some practice to train your brain to think and abstract this away. But eventually you'll get better and better at it. So we run, same functionality as before. And that is step 5, right? What parts can be generalized? We can also generalize the notion of checking for death, right? Instead of the monster, instead of checking if the monster dies, we're going to put this in the function and say, what if just the defender dies? And let's put, let's say that we're going to take the name field out. So it's going to be the defender's name. And we're going to say he screams for their life. There we go. So now, when you hit run, the monster screams for the life, and the hero screams for the life. So it's a pretty tragic outcome. But by putting the if statement here into the function and parameterizing what can die instead of like before where we just had the monster checking for death, we again expanded our program and made things more generalizable. Alright, so let's pop this into the debugger and see how the execution flows. So I'm going to paste this in right here. I'm going to set a breakpoint here. So every language really starts from line 1 and keeps going down. But when it hits a function, it goes into that function, wait till it's done executing, and then comes back to its regular execution flow. So let's see this in action. Here we go. Alright. So we're going to hit this print statement. I don't know why my thing is still not printing, but whatever. We're going to hit this hit function, right? I said that normally it would keep going down. But when we hit a function, it goes to where that function is, and it's not going to go back out to line 49 until this function finishes. So we go here. Right, so if this function calls another function, of course, then we're not going to return to 49 until the function that was called by this function finishes. In this case, we only have one. So here we finish this function, and then we finally return back to the line, the next regular line of execution. So 49, go back up, and then do the set of operations, go back down, and keep going, proceeding as normal. And that is how your program flows. Alright, so let's say that now we want a group of monsters instead of just one. How would we do that? So we know the data that we want to represent is already here, but we want to sort of group them together. So we're only doing these 2 steps really for now. So to do that, you use a list structure. So let's create a variable called group of monsters. It's going to be a list of monsters. So instead of having a monster assigned to this variable here, we're going to put one in here. So that's the first monster in this bunch. Let's create 2 more. And let's name this one spider. And this one's slime. And this one's a zombie. There. And let's change these for some variation. 5, 0. This is 20. And this is 20. Alright, so now instead of one monster, we hold a group of them. So let's delete this. Alright, we should get some errors now. So the question is, how do we get the group? How do we get a monster out of the group of monsters out? And to do that, we can use bracket syntax, and then the index starting from 0, like that. Why is this erroring? Oh, group of monsters. We deleted that variable. There we go. So I'm going to copy and paste this here. Paste, paste, and here. We don't want to pass the health. We want to pass the whole monster here, actually. There we go. All right. So same functionality, except now we have a group of monsters. So now let's say that we want the player to hit all of the monsters in this group, right? Imagine we're programming an AoE attack or like a giant sword swing that just wrecks them all. How would we do that? We would need to do an exercise in step 2, which is what operations can be done to these pieces of data. And what we really need is a for loop. I'm going to delete all this because it's clutter now. So we're going to look through every monsters in the group of monsters list, and we're just going to have the player hit them all. Player mod. So this mod here is a local variable to this for loop. We can name it whatever we want. It just has to be consistent with its usage inside the for loop. I'm going to rename it mon for now. And the first iteration of this loop is going to be this. It's going to be the spider first. Second iteration of the loop, mon is going to be the slime, and then the zombie. So if we hit run, the hero just brutally kills them all. Alright, so this is a little unnoticeable because we don't know what's going on for all the other ones, right? We haven't generalized line 47 and 53. All these two lines do is that they grab the first monster from the list, which is a spider, get its health before it got hit, which was 20, and then let it get hit, and then print its health after. But we want to apply this for all of these monsters because we have no idea what's going on really right now. So this is an exercise in generalization, and what we need to do, of course, is in the hint function, we're going to create a variable called health for attack. That sounds good. And we're going to assign it to the health before it got attacked. So it's the defender's health. We're going to make a copy of the defender's health before it got hit here. And we're going to print a message that will sort of display what happened. It's a really long one, so I'm just going to copy and paste it and explain it to you guys. So here we go. Let's break this down. I'm going to move this a little here. So we're going to print we're going to grab the name of the attacker, attacks, the name of the defender, and then the arrow representing a transition of the health values. So let's delete these two lines here, which only grabbed the spider and printed what happened. So here we go, click run. So the hero attacked the spider, went from 20 health to 0. And the spider gains for the life, which is this if statement here. And the hero attacks the slime, 5 to negative 15, slime gains for the life, and the same for the zombie. Alrighty, so we went from like a blank page, right, with a blinking cursor, to somewhat of a game, really revolving around these 5 fundamental questions of how programmers think. There's also a 6th one, which is blind spots. So remember the bug that we made earlier, right? This was equal, and we never considered that someone can be negative health. That's something that you don't really think to on a day-to-day basis. And it's a fault of our brains because we're not really meant to capture these details, these ultra-precise details, whereas the computer really needs the fine-grained details. So I've made a few exercises right over here that hopefully aren't too hard, and well, they progressively get more difficult, but we're going to walk through them together. And I encourage you to try these first before seeing what I did, because that's how you really learn. And it's intimidating to get started, I can say that. But once you do, hopefully it becomes an itch that you just really, really want to scratch. So let's start with the first one. So I have a folder called improvised, and I'm going to improvise this all live, I guess, in one take. It's going to might get a little messy because I get a little rambly sometimes, and my brain just fries, but it's part of the process. I might make some mistakes, so all the answers here are probably going to cover anything that I didn't do. So let's see, we can copy this, and here, paste in here. Alright, so the problem is that some monsters are allies, close this out, and some are friends. So make it so that the player does not attack them. So again, you're given a problem, maybe you don't know what to do, and you haven't really weaved how to think like a programmer yet. But I encourage you to pause the video and at least try to fill as much of these as you can. Some of these we're not going to be doing, so you can skip them. But again, pause and give it a couple minutes and try to fill out what you can to address the problem at hand. Alrighty, so I'm going to assume that you took a nice good swing at the problem, even if you didn't know how to really express your ideas in code. Writing them down and sort of vocalizing them really helps keep things straight in your head, and after you do that, it's just a translation process to the language of code. So let's start. Some monsters are allies and friends, make it so that the player does not attack them. So what of the three data types, being strings, numbers, and booleans, is best suited to represent what I need? So really, we need some way of keeping track of which monsters are friendly. And we can either use a number for varying degrees of friendliness. See, like a monster is 100% friendly, then we use 100, 50%, 50, etc. But for now, let's use a boolean for now, for simplicity. And it's going to be called isFriendly. That's the field that we're going to add to the monsters to test whether they are friendly or not. So isFriendly, friendly. We're going to say that you are not friendly. And the slime is going to be friendly, true, and then the zombie is not friendly. Alright. So let's move on to the next step. We're done with step 1. What operations can be done to the data to get to where I need or want to do? So we don't really need to operate on any data in the sense that we don't need to change existing data. We did add a field here, but we're not like decrementing or changing an existing field, right? We're not subtracting health, or we're not changing isFriendly to something else. So we can skip step 2. Step 3, what conditions do I need to consider to test and account for? So this is probably the key for this problem, because we want to make it so that the player does not attack friendly monsters. So the condition we need to check, of course, is to check if the isFriendly field is false, then we don't attack them. So in this for loop, if the monster is friendly, if it's false, equal to false, then we want to attack them. If it's not false, then it means, that friendly. So let's run this file. To run this file, strangely, you have to press Ctrl-Shift-S if you're on this website. Then you type in Python, and then the name of the file to execute. So this file is located in improvised P1 friendly. If you're doing these exercises in the web browser, it will probably create a local version, and you can just do like Python P1 friendly.py, which will run the exercise file here. But since mine is in this improvised folder, I'm going to go navigate to that instead. So Python improvised P1 friendly. So this is my version. We're going to run it, and we attack the spider, and we attack the zombie, but we do not attack the slime. And we successfully completed this problem of having friendly monsters as allies. And as you can see here, we print the whole list, and we can see that the slime's health is still 5, as always, unharmed. And that is problem number 1. So let's move on to problem number 2. New file, p2 armor. Guess what we're going to be doing here? Alright, copy this into here. Whoops, not OY. PY, silly. Okay, it's going to take I don't know why it's not syntax highlighting, but hopefully it does soon, or else I'm going to refresh the page. Copy this, paste it in here. Oh my god. Jesus. Alright, I'm going to refresh this page and hopefully it fixes it. And here we go. Come on. Finally. Alright, so the problem here is add armor to the game. Armor reduces the damage a unit takes. So again, pause the video and take a swing at it before we go over spoilers. If you don't know how to code it, try to fill out as much as you can here. Again, filling things out really helps keep things straight, and we can just translate it easily later. Translate the ideas you have, but you can't express later. Alright. So, I've assumed that you've taken a good swing at it. So add armor to the game. Armor reduces the damage a unit takes. Well, we need it represented by one of these three. And a number probably suits and does the job. So armor is a number. Alright. So what operations can be done to the data to get to where I need? Well, first let's add armor to all the monsters. So let's add armor, and let's say that it's a number ranging from 0.0 to 1. So if you have full armor, you're going to take full damage, right? If it's 1, you're going to take full damage. If it's like 0.5 for the slime, right, that's half. And if you're going to take like, let's do 0.5 again. Alright, so it's a number ranging from 0 to 1. Ranging from 0.0 to 1.0. So number 2 is what operations can be done to the data to get to where I need or want to do. So really that corresponds with this second part here. Armor reduces damage a unit takes. So how do we reduce damage? Well, in the hit function, this is where we do the reducing damage part. So really all we need to do is that we need to multiply by the armor field. So multiply by the defender's armor and take that out. And now the damage is reduced. So let's open up the shell again. I'm going to run this file. Python improvised p2 armor.py. So let's see. The spider takes full damage, but the zombie takes half damage, which is half of 20 is 10, so it's still dying. Let's say it takes maybe 10% damage of the original attack. So now it's 8. And let's make this a little more noticeable. Let's print out, let's see what happens before damage reduction. Right? So let's print armor reduces damage from, we're going to grab the attacker's health. I mean the attacker's attack points. And we're going to do an arrow. And then we're going to do the attacker's attack times the armor, which is what happens when we apply armor. Let's see, defender armor field. Okay, so click. If we clear this and then run it again, what the heck? Clear, run. Let's see. Am I running the right file? Yes, I am. Alright, so armor reduces the damage from 20 to 2. So the player has 20 attack points right here, but we multiply it by, this is for the zombie, so we take 10% of that, and that's 2. So 10 minus 2 is 8. So the zombie's health went from 10 to 8. And the spider still dies, but anywho, we just successfully solved this problem. We didn't need to do these other steps. But this is problem 2 done. And we just added armor. So let's move on to problem number 3 now, which is elemental. Fancy. So P3 elemental in this order. Not OY again. The The microphone is sort of in front of my keyboard, so I'm kind of missing keys here. Here, copy this file. Here, paste it in here. The steps for you guys. Here. Alright. And it's not highlighting it. Jesus Christ. Refresh the page. We're gonna have to wait again. I might edit this out, so it's fine. Come on. You can do it. Go, 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 go. No. Yay. Finally. Alright, so the problem for the elemental is add elemental types for every unit. So fire deals double damage for grass, against grass. Water deals double damage against fire. Grass deals double damage against water. Alright, this is sort of like the Pokemon triangle balance thing. So anywho, pause the video, try to fill these out as much as you can before we go over spoilers. And alright. Alright, so I'm going to assume that you guys took a good swing at the problem, so let's go. So add elemental types, deal double damage depending on the type. Alright, so what are the three data types? Strings, numbers, and booleans is best suited to represent this. We could use a number or a string, either one is fine. But we do need to keep track of it, of course, so let's make a field name. EL, let's call it EL, short for elements, is one of fire, string fire, string water, or the string grass. Alright, so let's do the player first. Let's add EL, an EL field to the player, and let's say that it's of type fire. Let's do that for the rest of the monsters. So here, we don't need this extra comma, it's in the way. Let's say the spider is grass instead, because that makes sense. Grass. And let's say the slime is water. And then let's say the zombie is, I don't know, fire again. And I've added a dragon to the group of monsters. It wasn't in the last exercises, so not to surprise you. Let's say it's water again from here. Alright, so that is step 1 done. Let's move on to step 2. So step 2 is what operations can be done to the data to get to where I need or want to do. So we want to deal double damage depending on the types. So to deal double damage, we just really multiply by 2. And that is step 2 done. We're not going to do it now, we're going to do it a little later. But let's do step 3. What conditions do I need to consider to test and account for? Well, the conditions are right here. If fire attacks the grass, deal double damage, and for all these other cases also. So there is a blind spot here. I'm not going to tell you, but let's just type this part out first. Let's see. So if the attacker element is equal to fire and the defender element is equal to water, and we want to deal double damage. So times 2. The defender will take double damage. And this is going to be repeated for these 2 cases also. So here and here. These will be elifs, because there's no point in testing them if we already know that the first one is not the one. So let's do fire. So we're here, water, this is fire, this is grass, and this is water. Alright, so take a moment and pause and see if you can find the blind spot here in this set of code and in this set of conditions. Alright, so the blind spot here is that we never really considered what if both elements are the same. Before, combat was not based on any elemental types. Now it is, and we need to consider what happens if a fire attacks a fire and water attacks water, vice versa. So for now, let's just say that else if there is no elemental advantage, then we just deal normal damage. Copy, paste. Right, it's not going to deal double damage. So let's run this. Control-Shift-S. This is the name of my file. It might be different for you if you're just cloning and editing a specific file. So improvise P3. Gonna make this bigger. Okay. Let's see. Go up a little more. All right. So armor reduces. This is for the spider. So the hero is a fire, and the element of the spider is grass. So when the hero, a fire, attacks the grass, we deal double damage. So we've completed this problem, more or less. It's kind of hard to tell right now when there's an elemental advantage, so let's just print that out. Let's print there was no elemental advantage. And let's do the same for the other ones. Here. There was. Let's just make this message. Mental advantage. Double damage. And let's paste these in for all the other cases. So this goes here. And this goes here. Alright, let's run the game again. Clear this. Gonna expand this a little more. Run the game. And for the why does it say there was an elemental advantage? There was no, and there was, because it was like the fire attacks the grass, right? That should be an elemental advantage. Oh, the bug is here. Grass. When fire attacks the grass. See, I told you guys there'd be blind spots. So let's just say that there were blind spots. Whoops. I even forgot to add this back into the thing. Anywho, that is elementals done. Alright, so let's move on to problem number 4, which is bugs. So I've intentionally added some bugs into this program. Some will be caught ASAP with red to indicate there was a problem, but some are silent. Alright, so let me just make a copy of this file. New file, come on, p4.py this time. Copy this. Alright. So, we're going to try to run this file, and we need to match the output, its print, with the one here. Alright, so pause the video, try to take an attempt at that before we go over spoilers in 3, 2, 1. Alright, so let's try running the file. Python improve p4. Here we go. So improvise if attacker EL is equal to fire, key error EL. It says the key error is EL. So the attacker is going to be the player, and it's going to try to take the EL field from the player. The player doesn't have an EL field. It has an element field, but not EL. So that was a bug in renaming. So I'm going to rename this element back to EL. That fixes that problem. Looks like we got another one on line 27. Line 27. Key error EL again. So I guess here, another one. I actually did forget which bugs I inserted into this. So this is live. Key error name. So line 41 is where it was hit. Name. Oh, names. There was an S here. So luckily these bugs are caught at sort of compile time, and you get error messages pointing of where they are. So let's see if this works. So this works, but it doesn't match this exact output. So this should be -20. This should be 0. And this should be -5. And this should also print. Interesting. So let's see. So this should be subtracting health, honestly. Let's see if that fixes the problem. So 20, 0 works. So it's this problem that we have not solved, right? Why is this -20 and this is 0? So it should be applying the elemental damage. This is a silent error. Grass, here we go. There's one extra A. So let's try this again. It's still not -20, so there's something else wrong. Grass. There we go. And this should be, wow. Alright, I think that's most of them. Or all of them. So 20 is 20, this matches this matches that. Matches, and matches. Alright, so this is bugs done. Let's move on to the next one, which is generalization. So let's create a new file. P.S I generalization. Hard word to spell in a way. Copy the stuff from here. This there. And we also need the steps. Before I forget, blind spots. There we go. Alright, so generalization. So we're going to focus on really these two parts, and this is the file with all the bugs in it earlier, I think. Yeah, we misspelled grasses and etc. So what the problem here is, we have a lot of repeating elements that can be further generalized for more maintainability and readability, along with preventing less bugs. So pause the video again, see if you can find repeating elements and see if you can factor them out into a variable, and generally clean this up so that we prevent feature bugs. And this is something that's a little harder to wrestle with for beginners, so don't worry if you don't get it. So spoilers in 3, 2, 1. Alright, so we have a lot of repeating elements. What do I mean by that? So fire, the string fire is repeated here a lot of times, among other things. So let's start with that first. So instead of typing out fire every time, that's stored in a variable. And honestly, let's reconsider the elements to use a number instead. So let's do, place it down here. Fire is going to equal 0. Water is going to be equal 1. And grass is going to be equal to 2. So by factoring things out and grouping them in a variable, we prevent these sorts of misspelling bugs to happen, because we can just do this. Whoops. Fire. So for all of the string fires, we replace them with the variable fire that just points to the number 0. Okay. So for water, okay. Grass, usually constant variables are capitalized for readability's sake. You don't have to capitalize them, it's just a stylistic choice. Grass. Alright. So now it's really easy to spot errors like this because they don't get caught at compile time. You don't get like a message saying where it is. But by doing this, we can more easily prevent typos. So fire. Whoops. Let's still some bugs in this. Let's just fix them real quick. Element. This was air, and this was grass. Alright, so we've done step 4 here. So what other parts can be generalized? And again, pause the video, see if you can find some similar parts here. This should be minus. And alright, so spoilers in 3, 2, 1. So you can see that all we do is get the attacker's element and check if it's fire against grass. We get the element of the defender. So we get the element of the attacker here, defender here, element of attacker here, element of defender here. So these parts are repeating, and they can be sort of generalized into, abstracted away in a sense. That we don't really care about the entire player, we just want to see, we just want its elements. So we can sort of leverage that out, pull that out by doing, let's call this has elemental advantage. It's going to take E1, E2. One is the first element, the other is the second element. And we're just going to do if E1 is equal to fire and E2 is equal to grass, then we can return that there was an elemental advantage. True. Alright, so let's do the same for the rest. 1, 2, L, L, and lastly, if all else fails, then there was none. Alright, so we factored this piece out, and instead of repeating, see, we have like the same print statements and the same double damage statements. So we can clean this all up to be if, let's see, has elemental advantage. Let's see, we're going to pass in the attacker's element and the defender's. Okay. Then we can just do this once. Copy. Paste. Here. Else, we get to do this last part still. Copy. Paste. But we can just delete all this junk now. Right over here. Gone. So we no longer have these repeating statements, right here. It's just one now, and it just looks more cleaner. Along with other things, let me just redelete this and fix these here. So fire against grass was water against fire, and lastly, grass against water. So we should get the same output, right? Same functionality. Nothing's really changed other than that. Our code is, less prone to bugs. It's more maintainable, and arguably it's a little more readable. So let's run this. Same output as the last one. And you can verify that for yourself. And there we go. This is generalization. I just realized I ran the wrong file. So Python improvised P5 generalization, and we have some errors, of course. So vendor EL. I accidentally typed E1. Whoops. Really hard to notice, right? Because the one kind of looks like an L. But here we go. There we go. Now it's the same output as the previous. And yeah. So generalization is something that takes some practice to sort of hone your skills and see repeating patterns and really know when to get a feeling to abstract it away. Don't worry if you don't get this the first time. These two are one of the two hardest of the 5 questions that you ask when you normally program. So let's move on to P6. Go over here, add file, P6 healing pi. Sorry for the background noise. I'm going to copy, paste in our steps over here. We can go close that. Alright, so the problem is if the elements are equal, heal the attacked unit opposed to damaging it. So take a pause at this video right now, write down as much as you can before we translate the ideas to code. In spoilers, in 3, 2, 1. Alright, so what 3 types of data, strings, numbers, and booleans, is best suited to represent what I need? Well, we already have all we need, so we don't really need to do this. Number 2 is what operations can be done to the data to get to where we need to do. So really healing here is the key. Healing is adding health. So we need to add health. Health to heal. Alright, that's one down. Let's move on to the next one. What conditions do I need to consider to test and account for? Well, out of this sentence, out of the problem sentence, we need to sort of compare when the elements are equal, or like when they're not equal. So if we have a grass attacking a fire, it's not really an elemental advantage either. So we're just going to say that it does normal damage in that case. So let's see, that part is done. So let's start writing some code. If the elements are equal, heal the attack unit opposed to damaging it. So this is where we apply the damage mainly. So this else statement will run when there is no elemental advantage. So while we're here, we can do if the attacker, I am really sorry for the background noise, EL and defender element, right? If they're both equal to each other, then we are going to heal instead of reducing damage. So that's step 1. Well, it's step 2, honestly. So we need to add back health. Do we want to take into account the armor? I think we shouldn't, honestly, because it doesn't make sense if you're not really taking damage. So let's just do that. This is our choice though, so right over there. Otherwise, we're just going to heal. We're just going to do the attack like normal. Alright, and let's print out here. Let's print out who healed who. So the space, get the attacker's name. Heals, comma, defender, name, and let's do the previous and before. So health. So we're gonna do let's see, this health before attack, another arrow, and then the defender's health. Let's see, defender health, HP. Honestly. Oh wait, so it should be its previous health. It's health before the heal. Yeah, so it is health before attack. So let's see. Missing a comma here. Alright, so let's run this. Python. Improvised. improvise/P6. Did I spell that wrong? Oh, this is not the shell. Control-Shift-S. Let's see. Here. Python improvise/P6. Alright, so let's see who healed to. So, there was no healing. So is there a bug here? Let's see. If their elements are equal. Oh, this and is should not be here. Oh, that was a brain fart for me. It should be equal. Here we go. Yeeshers. So now there should be healing. There we go. So the hero heals the zombie because they're both they're both fire types. So we're adding 20 health to 10, and it's 30, and that is healing. Alright, so let's move on to P7, which is called Fight Back. So let me just add a file called P7 underscore fight back dot py. Copy and paste this stuff here. Sorry for the background noise, it's just I can't do anything about it. So we're going to copy and paste this here. Alright, so what is the problem for this one? Make a war between monsters and humans, create a heroes party, and have the monsters fight back at the heroes. However, monsters should not attack humans that are friendly. Alright, so again, pause the video before we go over spoilers. Write down your thoughts as much as you can, and we will try to translate those and express them in the language of programming once again. So, 3, 2, 1. Alright, so let's try to break this sort of abstract problem down. So create a heroes party and have the monsters fight back the heroes. So create a heroes party means that it's what is this? Plural. So what we need is a list. So this really corresponds to making a list of units. And let's see what else we can take out. Let's see, make a war. We'll do this later. However, monsters should not attack humans that are friendly. So that means that all hero units should have a is friendly field also. Okay. And let's start with this right now. We'll go back to step 2 later. Start creating the data we need. So right over, where should we create it? We'll create it over here. This group of humans is going to be equal to this. This is going to be the heroes party. Let's just paste in our hero in there. We can start deleting the player now. Let's see. We want an is friendly field, right? Because monsters should not attack humans that are friendly. So let's add that in. Wait, this is step 1 again. Let's see. So is friendly. And let's say he is friendly. He or she is friendly. So false. Oh, wait, true. Whoops. Alright, we need, let's see. Let's make a few more. 1, 2, 3, 4. So let's name you a goddess. I'm not even sure if I spelled that correctly, but let's just go with it. Let's make a mage. Let's make it a knight. And like a merchant. So the merchant is not a friendly person. And let's see. Let's make the goddess not that friendly either. Alright, so that's all the data set up. So now let's move on to step 2. What operations can be done to the data to get to where I need or want to do? So we want to make a war between monsters and humans. And that really means that they should be hitting each other. We already have a version where like all the monsters get hit by a player, but we don't have the other way around. So let's just do this. And this is, let's see, we're going to make another loop for human in group of humans. If the human is friendly, this is also equal to false. We're going to hit, this time the monster is the attacker, and then the human is the one that's taking damage. So you'll notice that there is no mon variable in this loop. So what we need to do really is that we need to have another for loop in here, because we want all the monsters to attack the humans and all the humans to attack the monsters. So how this is going to work is that the hero is going to attack this. Goddess is going to attack 1, 2, 3, 4. The mage is going to attack like that, and it's until these all finish attacking, the monsters are going to attack back. Alright, so let's just write the double for loop. So for every monster in this group of monsters, each one of them is going to get a turn to attack the human. And the same with the other way around. So for every human in the hero's party, right, group of humans, we're going to hit the monsters. There we go. Alright, so let's try to make these different because they're all the same. Let's say that text 2 here, let's do 30 here, let's do 5, and let's do 1. Let's make you 6. We're just randomizing these. 5, 7, 10. We are also forgetting an armor field for the player. So let's put that in. That's something that we didn't account for because our code sort of evolved over time. So we try to run this code, it won't work because, let's see. Improvised. P.S I. So it would crash eventually because the heroes, group of humans don't have armor. So let's just add those in. So let's add some armor. Let's say that hero gets like no armor, I guess. Armor is just takes full damage. Gonna copy paste this for all the other lines. Copy, paste, pasty, paste, paste. So let's say the goddess takes half damage. You're going to take full damage. You're going to take 10% damage. Sure, why not? And let's do, I don't know, let's do 10% again. Why not? Let's also change their elemental types. So you should be water. The mage would stay fire. You would be grass. And you would be grass too. Why not? Alright, so it crashed earlier because it was trying to take the armor field from the set of humans, and they didn't have an armor field. So that's why the hit function crashed earlier, right here. Right, it says key error armor. You couldn't get it from the group of humans, but we fixed that issue. So now, we run our code. It should work. And we have a giant sprawling battle. Okay. So the operations we needed to do is we needed to loop over all the monsters and have every one of them attack every human. So it's the same the other way around, right? We needed every human to attack every monster, and there are 2 everys in this sentence, and that is a sign for when you need a double for loop. So that might be a little too hard to sort of grasp if you're a beginner. But again, as time goes on, you're going to train this intuition. Anyways, this is Fighting Back, and let's move on to the next one. So actually, I just want to go over this one more time. Notice how we're distilling the problem, and we're breaking it down. So make a war between monsters and humans. Well, what does it require? Well, we needed to create a hero's party because we only had a singular player earlier. And we want to have the monsters fight back against the humans, and vice versa. And we also did this condition too. So, yeah, I just want to emphasize that really, as you program more, doing these steps will be more faster to do on your head. But again, sometimes it's just better to write it down so that you can have some basis of sort of reasoning. Alright, so I've taken the liberty to pre-paste everything all ready to go. And the problem is that I randomize all the stats, HP, attack, armor, element names, for the monsters and players. If the attacker tries to attack a friendly unit, have a random chance that said attacker will turn friendly. And this is probably the hardest one out of all the other exercises. It requires us to sort of read about the API of how to use random numbers. It's importing someone else's code right here, this line, and pretty much you just Google and just look up examples and try to shadow what you see. So we're going to need something like choice, right? So we'll choose a random choice out of this. We're going to need this for armor. It's a uniform, and we're going to need a range to generate a random range between like 0 to 9 or something for all these random stats. So it's okay if you don't get this because again, this is going to touch mostly all of these areas, honestly. So yeah, don't fret about it. Alright, so let's start doing this. Let's start by randomizing all these stats. So to do this, we can just call random, import it from above, and do rand at 100. This can give us a random number between 1 and 100. So let's do this for attack, health, attack, health, attack. See, we're going to have to keep doing this for all the other ones. And if this is, sort of hitting number 5, then you'd be right. So let's just refactor this right now because I'm too lazy to paste all of these in. The one thing that's different from the monsters and humans is really the class names, right? So the name, knight, merchant, where's the other one? Mage, hero, goddess. These are exclusive to the subset of humans, and likewise for monsters. So we need to sort of group them together. We gotta group related pieces of data together. So let's just start doing that. Let's do it here. So list of human classes is equal to hero, goddess, mage, knight, and merchant. Okay, let's do that the same for monsters. Monster classes. Alright, so we can generalize a unit because a human has health, armor, attack, name, elements, friendly. So this is a monster. So we can generalize this to a function called generate random unit. Name is the only thing that's really significantly different. And we're going to return a new one with all the fields. So let's just copy, paste. Return. So health is random. It's randomized, and this will be uniform. 1, 2. No. That will give us a random number back between 0.01 to 1.0. Let's see what else. This name should be parameterizable, substitutable, and this should also be randomized also. So random choice, right? I got it from here. I'm going to randomize true and false. So pick between one or the other, and this code will generate a unit. So this generates random units, but we want to generate a group of them. So we can generalize that by defining a function called generates. Well, let's call it create group classes, and we're going to create the group in this function, a general group, and we're going to make for num range 0 to 10. We're going to push into this group list above here the let's see, a random unit. So we're going to say choose between one of the classes that we give, which are the lists here. Alright, so instead of group of humans being something that we manually type out and always like keep pasting like this, right, if we want another one, we just randomly generate them in a loop and create them in this temporary function, and then we have to return it from this function group. Alright, so now this can be just all removed for group, pass in the list of human classes. And we're going to do the same for monsters. Let's see, for monsters, it's this. Copy. Paste. Alright, so this also needs to be randomized. Alright, so we have done this big part here. We created a lot of functions to generalize the creation process of randomizing all the stats. And this is, again, kind of hard to conjure up when you should make a function and stuff. But again, you're going to develop the taste eventually. Alright, let's do this last part here. If the attacker tries to attack a friendly unit, have a random chance that said attacker will turn friendly. Alright, so really this is an exercise in here. What conditions do I need to consider to test and account for? And it's like branching. So most of the attacks start here. And what we want to do, of course, is to make sure that when we attack someone that's friendly, right, we're not even trying to attack someone that's friendly, but if we see someone that's friendly, alright, so let's try to do this last part here. If the attacker tries to attack a friendly unit, have a random chance that said attacker will turn friendly. So this is an exercise of here. What conditions do I need to consider, branch, test for, and account for? So all of the attacking happens here. And ultimately, we already check if the monster is not friendly here. So all we need is an else statement. We could do else if and check if the monster is friendly, but there's no... we already checked if it's not friendly, and this else pretty much does the same thing. So else if, or else, we're going to do a random chance. True, false. That this monster turns friendly. Let's see. Is it true? And let's do the same for humans, except it's the human that turns friendly. So go back here. I gotta re-indent this. Here. And here. So this time, it's the human that might turn friendly. Right? So it's the goddess and the merchant at first, then we have to worry about. Anyways, this is mostly it. So let's run this code. Control-Shift-S again. Python improvised 8. We got some errors, which is fine. We'll just fix them. So random has no uniform. Attributes uniform. What? So this is on line 56. So uniform. I form. Didn't even spell it right. So clear that. Run it. And we have a large sprawling battle with monsters, random generated monsters, and heroes. Alright. So this was a pretty big change. And don't worry, if you didn't get this all the first time, we're going to go over this in the next one. So I've already pasted part 9, the end game. We're finally here. So the problem is randomize who attacks who and make it so the war goes on until everyone is friendly or everyone else dies. Because right now, everyone's attacking sequentially. So all the humans hit the monsters first, and then all the monsters, the humans afterwards. When what we really want to do is do something like a human attacks some random monster somewhere, and then the monster attacks some random human somewhere. Because we want sort of random order on this. So let's start breaking this problem down. Pause the video. Maybe you should fill this out. Again, this is one of the harder ones, and I don't blame you if you don't want to, or you can't really wrap your head around it. But anywho, spoilers in 3, 2, 1. Alright, so let's do this one first, this one second, and then this one last. So the war goes on until everyone is friendly or everyone dies. So ultimately, that means that I don't think everyone can die actually, because the way we set it up is that if it's not friendly, they're not going to attack each other. So eventually, a fire is going to meet a fire type, and they're just going to keep healing each other, right? And until they turn the other one friendly. So that's nice. Not everyone will die in this case. Alright. Let's see. The war goes on until everyone is friendly. So let's break this one down. Copy here. So, war goes on until everyone is friendly. Well, who is everyone? It's the group of monsters and the group of players. And it's when they are grouped up and friendly, the game stops. So this is a while loop condition because for loops usually rely on knowing the range of stuff. So for loop here, for example, we know the range. It's going to go from 0 to some random, not some random value, but it's going to go 0 to 10. While loops depend on a condition. So let's start doing a while loop. So here, let's do while. Let's call it existing unfriendlies. We're going to give it the group of humans and existing unfriendlies. We're going to give it a group of monsters here. And this all needs to be indented. Here. Let's see. Now we've got to create this function. So let's do this. Existing unfriendlies. It's going to take in the group, some arbitrary group, and your job is to write this function. It needs to return a boolean because when it returns something, this is going to be substituted by this function call. So it's going to be like false here because we're returning false here. So do your best to fill out this function. It's okay if you don't get it. But spoilers in 3, 2, 1. So to fill out this function, we want to loop through over the group. So for unit and group, and we want to check if there is an unfriendly. So, and if so, we got to return true. But that is not going to work well because the for loop is going to kind of consume that. So we need to store a result here and do this. And then return the result here. Alright, so we're going to loop to the group, check if the unit has an unfriendly. If it does, we're going to set the result to true, and we're going to break here because we want to stop searching after we found one unfriendly. And this should work. So if we run the code, we might be here for a long time because we haven't finished these two. Randomize and print who died on each side. So let's do these other two. By the way, it's Control-C to stop running. So let's do randomize who attacks who, right? That sounds like a good one. So what we need to do is that we need to pull out a random human and a random monster. So in this while loop, let's create some variables called E1 and E2. And we no longer need these anymore. I'll keep them there just in case. Humans, random, randint, 0, length of how many humans there are, -1, because raised start counting from 0. Let's do the other one. Group of monsters, and group of monsters. All right. So that's the first step in this process. Secondly, we want to randomize who is the attacker and who is the defender. So let's just write this out. It's if random.ran is a choice, give it true or false. I'm sure there's another built-in function that does the same thing. But anywho, if E2 is friendly is equal to false, basically this part here, then we want to hit them. So E2 will be the attacker, which is the human, and it's going to hit the monster. Otherwise, want the random chance of them turning friendly. So here, copy, paste, dot, gotta indent this. Come on. Here, here, and this is, let's see, E1, right? This is the attacker. So let's do the other case. So else, we want the monster to be the one attacking. And it's just this repeated logic here. Okay. We're going to delete all this part here. We don't need it. This time we want to swap it. So if E1, if the human is friendly, then we want to, not friendly, then we want to attack them. Otherwise, if they were friendly, then we want a random chance for that friendliness to influence us. So this is E2, because we're the one hitting over here. So anywho, let's just run this, see that it works. Let's see, some typos. So unsupported operand list int. Let's see. Oh, this has to go outside, I think, right? No. Line 95. Random. Int 0. Parentheses. Unsupported operand minus list int. Group of humans. Oh. Yeah, this has to be outside. Because length will give us a number. And it only wants a list. So here, verify that this works. Hit run. Oops. Run it here. And here we go. So it doesn't infinitely loop, but they're still not really fighting until the end of time. Right? Until existence and friendliness, these two are false. We still need to do this last part. Right here. And let's deconstruct that. So secondly, we want to randomize who attacks who. So sometimes it's the monsters attacking the humans, and then the other times it's humans attacking the monsters. So to do this, we need to do something random. Choice false. This random choice will determine who attacks who. In this case, let's say that it's E2, so it's the monster that's being attacked. Is friendly. False. We're going to hit monster. 2. Oops. Otherwise, we want a random chance, which is this here, to turn friendly. So true, false, and then this is E1. So we want the attacker to have a random chance to turn friendly. Is friendly is equal to true. And there we go. We want to apply the same thing for the other way around. So let's just copy this. Let's see, copy and paste. We need an else clause here. The other way around. Go here. Space this out. See here. Else if else. Huh. No idea what's wrong here, but let's just fix this. This time, the human is being attacked, and the monster has a random chance of being friendly. So else if, oh. This has to line up. There we go. Alright, so that is fighting. So we're going to remove these because we don't need them anymore. And let's watch them fight. So clear. Let's see. Unsupported operand, negative, list, and int. So line 95. Oh, this length function only takes in a group of humans or a list. It doesn't subtract one here. We gotta do it outside. That's the bug fix. We're gonna run this again. And they're just gonna keep fighting each other. So you notice that there's a bug here in the sense that some monsters have negative health, so that means they should be already dead. And it's this problem that we have yet to solve, and that should fix this final bug here. So here we want to print the amount who died on each side and the total amount of casualties. Ahem. Sorry, I have a hiccup. So there are a few problems here actually. We want to remove people who are already dead from the battlefield to a new list. So let's create a new list called casualties. Casualties. And this will be the graveyard, more or less. Graveyard. So we'll just do it right under here. So for index in range 0, length of humans again, here, paste. Alright, so unmatched parentheses, so let's just match that. Let's see, unmatched parentheses again, range 1, 2, I think we had too many. Yeah, okay, I think it was too many. Alright, so this will loop through all of the humans. So let's do human is equal to the index of all of them. And we want to check if their health is less than or equal to 0. If so, then we remove them from the list and we add them to the casualties. So we add it to the casualties, human, and then group of humans. Pop will remove them from the list. It takes the index, so here, and it's the same process for monsters. This, of course, you can generalize this, but that's an exercise for you guys of monsters. You can see patterns here that are really eerily similar. So here, append the monster that died to the graveyard, and pop its index too. Alright, so lastly, we want to print the amount of casualties and the amount who died on each side. So I'm just going to copy and paste the print statements because, I mean, they're not really interesting to look at. Copy here and paste. So max num in group, we need that variable because I abstracted the generation. So max number in group is equal to, let's say, 10. So paste this here. This was a unit. Where's the group? Here. So let's just paste this down here. Okay. What else is wrong? Max num in group. Whoops. So num. And here. So by doing this sort of teasing this piece out, we can reuse the number 10 here for generating the group and printing the amount of casualties. So let's play this. And the war has ended, but there are 1 casualties. Well, it's pretty good. 9 out of 10 humans survived. 10 out of 10 monsters have died. So play this again. 0. I didn't think we would hit that. 1, 1, 0, 1. What the heck? And we actually hit a bug here for some reason. So let's see. Oh, this is why. This should look more like what I expected. Monsters. Monsters. Oh my god, yes. This is what you get for copy and pasting. So, run this. Yep. This is what we expect. 0, 2, 5, 6, 0, 1. Are we sure that we have everything? Yeah. Alright, so we've written a lot of code. I don't expect you guys to sort of understand what I just did without looking at a debugger. So let's just break it here, run debug on this file. So it creates these variables. Keep going, nothing interesting yet. So a group of humans, we're going to go into this create group function. Go in here, empty list. We're going to create 10 humans. So it's going to call this generate unit function. So it goes somewhere. It's going to randomize all these sort of numbers. And it's going to go back out. So far we have a, let's see, hero in this party. So let's keep going. It's going to generate 10 humans. Let's do a couple more. So push this into the list. We have a merchant. So it's going to keep doing this about 9 to 10 times. Let's just step out of this now. I think you get the general idea. So it's going to create this group and put it in the group of humans. Let's check what that is. Group of humans, where are you? So we have hero, goddess, knight, mage, etc. Same process, but for the monsters, right? Go into group, create the group, generate random monsters. So it's a dragon, now it's a zombie, etc. So go back up. After this is done, we now have 10 monsters, all randomized, 68, Lord, 13, etc. Alright. So casualties is empty right now. This is just defining the function. So this is where all the magic starts happening. So let me clear my voice for a second. So is there an unfriendly in either of these two lists? There probably is one. So let's go in here. This unit is not friendly. So this hero in this party is not friendly. So we're going to go set the result here into stop searching. And there we go. Result is return this result. Okay. So now that I think about it, I think this should be an OR, right? Because if this returns false, then, and there's still existing unfriendlies on this other side, this whole thing will be false and the war won't continue and there will still be unfriendlies left. So my bad, that was a bug. OR. Whoops. So go back up here. I was going to loop through all the list to check the monsters. Both of these are going to be true. We're going to randomize who attacks who. This time it's the merchant attacking the dragon. So we're going to go through all these. Check the limited advantage stuff. And print these all out. So anyways, I hope you guys get the general idea. I'm really tired, I'm sorry. This was a bug. Again, I'm gonna fix that right now. Over. What the heck? Or. There. Now the war continues until both sides don't have unfriendlies. Let's try it with 100. Oops. Is there a breakpoint anywhere? No. We're just gonna run it. Let's see. War has ended. 28 casualties. 40. 26. 29. Let's do. Let's see. 1,000. Here we go. Let's see, 363 casualties. And yeah. Man, this game is depressing. I don't know who made it, but anywho, thanks for watching, and I will catch you in the next one.